Hi everyone. Okay, so we're going to start talking about exponential functions now. And so we're just going to work through this problem real quick. If we have, let's choose some values for x. Let's say we choose -10, -2, -1, 0, 1, 2, and 10. And let's determine the y values for each of these. All we're going to do is we're going to use these as the powers. So let's start with 0. We have 3 to the 0, which is, everybody knows, these are the x's, these are the y's. 3 to the 0 is going to be 1 because anything to the 0 is always 1. Oops, let me make that a little bit neater. So we've got 3 to the 0 power. We have 3 to the 1. Well, that's just 3. 3 squared, which is 9. And 3 to the 10th, I don't know what that is. It's a big number. We'll just put, for now, let's just do 3 to the 10. We don't know what it is. Okay. So, if we do the negatives, remember a negative power is going to flip it. So this is going to be 1 over 3 to the 1, which is simply just 1/3, 1/9, and 1 over 3 to the 10. Okay, so since 3 to the 10 is a big number, 3 to the 10 is 3 times 3, so we've got 81, which is 81 times 81. Remember, this is 3 to the 4th times 3 to the 4th times 9. And obviously 9 because that's 3 squared. So as you can see, this is a pretty big number. If this is a big number, then this gets increasingly big. And so the graph of this is going to look something like the following. We have the graph here. These values for the negatives are going to approach 0, but they'll never get to 0 because you're taking 1 and you're dividing it by very many pieces. So for instance, if you do 1 divided by 8,000, you're going to have very tiny pieces. They're not going to be 0. It's not that you're going to have nothing. You're just going to have a very small piece. And so it won't be 0 itself, but at the same time, it'll be very close to 0. But if we look at -2, we know that's 1/9. We look at 0, that's 1. We have something up here at 1/3, at -1, at 3, at 1, that's right here, and so on and so forth. And so our graph looks something like the following. Okay. Which is very similar to y equals 2 to the x. It's obviously just a factor of 3 instead in this case. So we've got that. So what's the domain of this function? Well, if you know, I always say this. Is this going to be divided by 0 if I plug any value for x? The answer is no. Do I have any fractions? I mean, they technically turn into fractions, but you'll never have something divided by 0 because 3 to any power is never going to be 0. So the domain is going to be -infinity to +infinity. Oops. Okay. And then will the y values ever be negative? So we kind of look at this. These get very close to 0. However, even negative values still are positive values technically in the y values. And so the y values will never be negative. And so since they'll never be negative, 0 is our lower bound and infinity is our upper bound. As x approaches -infinity, what value does the y approach? Obviously that's 0. So for this one, y approaches 0. Is the function increasing or decreasing? Well, we read that from left to right. This is increasing. And is the function 1 to 1? Well, if it passes, this is obviously a function. It's called the exponential function, but it also passes the horizontal line test, as you can see. And so 1 to 1. Okay, and that's important, right? Because we know that if something's 1 to 1, then it has an inverse function. Okay, so we can look over here. And if we wanted to swap these, we have our values for x and y. We know that the inverse would have the opposites. You'd switch x and y. You'd have 1/9 being -2, you'd have you'd have 1/3 is -1, 0, 1 and 2, this would be 3, this would be 9, this would be 1. Okay, and these are your y values. And so it says, what is the range of this function? Well, we know that from earlier when we talked about inverses that we switch the domain and range. So since f inverse of x, we switch the x's and y values, that means the domain and range from here switch. So the domain of this thing is going to be from 0 to infinity. And the range is going to be from -infinity to infinity. So we figured the range out. Will the x values ever be negative? Once again, since they switched, no, they will not. No negative x's. Obviously, that's dependent on if there's a shift or not. If there's a shift, then you can have negative x's, but there is no shift here because we do not have, remember our original problem was not something like y is equal to 3 to the x minus 2 plus, I don't know, actually not plus, minus 4. That would allow us to have negative values because it would shift the graph down. However, actually, the range values would have some negatives in there if that was the case. But since we don't have that, we don't have any shift. With that being said, how do the domain and range relate to the domain and range of function f? Obviously, the answer to that is they have shifted, they have switched, they have replaced each other. And so with that being said, I think that kind of reiterates the point. If we do the graph of this one, it's going to do something similar to this. Oops. Going through 1, getting close to 0 over here. Actually, let me make it a little bit closer. Going something like the following. And increasing this way. And so these are your inverse functions of one another. This is the graph log 3 of x. And so this would be our first introduction to a logarithm. Thank you, guys.